Next, we need to talk somewhat about pointers and functions. Oh, this is going to be good. Oh, this is going to be fun. All right. So let me go close this out. CP pointer array. CP to pointer and functions. Oh boy. Here we go. All right. So if we want to do int add int star a, whoops, int star b, so we could return star a plus star b, and that would actually work just fine. Let me go ahead and write a quick for loop. Int I equals 0, I is less than 10, I plus plus, p sub I equals 10 plus I times 10. So it's filling up the array with 10, 20, 30, 40, 50, 60, all the way up to 100. And then we could do, now let's see, add of p comma p plus 5. All right, what's the output of that? Well, first we have to think about what's being passed to add. What's the function add taking? It's taking two parameters, and what are both parameters? Pointers to an integer, correct. So they're going to store the memory location of where an integer resides. That's what those two things are holding. Then you're going to dereference A, jump to that location, get the integer, and then also go to B, jump to that location, get the integer, add them, and return. So the first one we pass is P. What's the value? What is P's value right there?
10.
Not 10. It's the
first element in the array.
It's not the first element of the array. What is it exactly? What is P?
Memory location.
It's the memory location of the first element or integer in the array. And then P plus 5, what's that?
The second memory location of the fifth element.
I don't know why you said the second.
I don't know why I said it.
It's not the fifth, but the sixth element, right. So the first element is what?
10.
10, and what would be the sixth element?
60.
60. So we should get
70.
70. All right. Good, it compiled. Perfect. Any questions on that? All right. I'm going to create another little function. I'll call it fun. We'll leave it like that. All right. So fun is also a function that takes two parameters. Each parameter is a pointer to an integer. Namely, each parameter is going to store the memory location of where an integer resides. So what's the first thing that happens down here in the function fun?
Increments A by 1.
It's A by 1, which is incrementing A by actually how much? 4. And then what's happening to B? By 1, which means you're subtracting actually how much? 4. And then you're returning the dereference of A and B. Okay. So what should the output there be?
Third element of P.
Well, hold on. P plus 1, you're passing in P plus 1. Which element is that pointing to?
Second.
The second element. And then A is doing what? Adding 1. So now A is pointing to the third element. So the dereference of the third element is
30.
30. Perfect. So we have 30. P plus 5 is the
6.
sixth element. Goes in the function. What's happening to B? So now it's pointing to the fifth element, and it dereferences that. What's the fifth element?
That's
50.
yeah.
So it's doing 30 plus 50, which is 80. Perfect. All right, some people get confused about this. What is the dereference of P right here?
10.
Correct. P did not change, right? Because these are passed by value. So it's copying whatever memory address is generated here and putting it there. So it's a copy. A is holding a copy of the memory address. So it's not changing it.
If you, just to clarify, if you output right there just P, no star,
Whoops.
that would just give you the memory location of the first variable in that array.
Right, you got it. The memory location of the first variable of the array. You got it. All right, fun 2.
Ow.
Okay, so fun 2. It's a function that takes 2 parameters. Again, both of them are pointers to integers, so each parameter is going to store the memory location of an integer. Down to fun 2. We're going to dereference. What does this one do? Dereference the first element and set it to 200. Dereference the second, set it to 300. So I'm passing in P and then P plus 1. What's going to be the output of this next line?
It would be 10 again.
So P is the memory location of the first element, correct? So A is going to hold the memory location of the first element of the array, correct? So then what's the first line doing? Setting the integer that A points to 200, which happens to be which element of the array? First. So when we print out the first element afterwards, it's going to be, yep.
Changing it inside of that function changes it in the main function.
Yes. Well, no, remember, you're passing a pointer, so you're actually changing this piece of memory over here. Remember, this memory is out in the heap, so you're passing where that memory is located to that function so that you can change it. So I wanted to say yes, but I wanted to make sure it was clear what exactly was going on. Yes?
Why did that function have to return something?
Because it's C++ and we don't care.
Okay.
The official declaration is the return value is undefined.
So with pointers, when you pass them into a function, they can be updated.
The memory that they point to can be updated. When you pass a pointer like this, you don't update the pointer that's being passed. When you use it this way, you're passing it by value. So remember, the memory location is being passed by value, but what they point to can be changed.
So basically, it's keeping the same memory location, it's changing the value.
The
That's
value.
in that memory
Mhm.
location.
All right? Any questions there? Because I'm about ready to trick you up.
I guess it's confusing because in convention, you would pass in, if it was normal stuff, if it was normal integers,
Mhm.
and you passed in 10 and 20 as A and B, and then you set A equal 20, function ended, and you didn't change what you passed in, you know what I'm saying?
Correct. That's
it's-
correct.
Because it's a pointer, it's changing the memory.
Because you're jumping to the memory location. And since P and A are pointing to the same memory location, what they're pointing to is going to change. The values that at that memory location will change, right? All right, now I'm about ready to trick you up. Oh yeah, that's totally illegal. I'm going to keep it nice and simple. Okay. Function 3 is a function that takes one parameter. The first parameter is a reference to a variable that points to an integer. Did y'all do pass by reference in procedural?
Yes.
Good. So, what do you think that means?
I was thinking it would just dereference itself, but.
No, remember this is
Yeah.
parameter declaration. A becomes an alias of what's ever being passed in. So anything that happens to A also happens to the variable that's being passed in because it's passed by reference. So that means when you pass P into this function, P is going to be incremented by 1 because you're passing it by reference. So then when you output P, what value is going to be put out?
A plus 1.
When you dereference P after calling fun3, what value is going to be printed out? The second element of the array, which is
Would be 1.
not 20, because we called fun2, and what did fun2 do? Oh, yeah. So it's 300. 300. Okay. Yes?
That, the ampersand made it pass by reference?
Yes. The ampersand in a function declaration makes it pass by reference.
So
The
if you-
ampersand in code generates the address of something.
So if you hadn't have passed the ampersand,
Then it would do nothing. It'd increment A by 1, but A was a temporary variable of the function and not affecting P.
Oh, I see.
that's what I thought would happen with the previous function, though.
It is. A is a temporary variable that holds the memory location in P, but you're jumping to that memory location when you're dereferencing and storing 200. P and A are both storing the memory locations of the same element, so when you
And A
dereference-
changes.
Yeah,
Okay.
store changes what's being pointed to. Yeah.
So it's not changing P, A is changing what's at P.
You got it.
That makes sense.
Yeah, you got it. Any other questions? You good, Jonah? You got this?
Yeah,
You're ready? You got pointers down?
yeah, got it.
Come on, guys. It just stores the memory location of something. All right. So we talked about that. Function can return a value of a pointer. Yep, you definitely can do that. We're not going to go into that right now. Okay. Annoying thing about C++ is you can, from every time I've used it, they have yet to update this, you cannot instantly declare a two-dimensional array. Lame. But anyway, on the heap, what you have to do is you create the array, and then you have to individually create every single row. That's all this is saying.
And in Java, you could just put another set of brackets.
In Java, yes. Yeah. Okay. I'm going to stop that